This is your lesson for Chapter 3, Section 10. It's about relations. Okay, the objective is listed here. It's to graph relations, so we're going to graph relations and determine whether relations are functions. Okay, so first thing we need to do is define what is a relation. Well, we've talked about these. Okay, in this case, it's any set of ordered pairs. Remember, these right here are ordered pairs. The set of the first coordinates in the ordered pairs is called the domain. We've talked about that. And the second coordinate is called the range. The domain, we'll think about the domain. The domain is usually the x value, and the range is usually the y value. So here's an example. The set 1, 2, 3, 4, 3, 5 is a relation where D is the points 1 and 3. The domain is the points 1 and 3 because those are the x values, and the range is 2, 4, and 5. Now, a specific type of a function or a specific type of relation is a function. Now, it's a relation in which different ordered pairs have different first coordinates. Okay, so the example that we have here, 0, -1, 2, 3, and 5, 9, 0, 2, and 3 are all different. However, if we look at the second one, 3 and 3 are the same. Since they are the same, it means it's not a function. Okay, these were all different. 0, 2, and 5. These are all different. So those are not functions. So it is a function. Okay, 0, 1, 0, -1, 2, 3, 5, 9 is a function. 1, 2, 3, 4, and 3, 5 is not, because this has x's that are the same with different y values. Now, vertical line test is a test to determine whether a given relation is a function. And we'll look at that here in a second. Okay, the test says that a relation is a function if and only if no vertical line can intersect its graph more than once. I'll show you what that means here in a second. We've got some symbols. This symbol here that says the set of all ordered pairs, okay, x, y, such that the absolute value of x plus the absolute value of y is equal to 1. Okay, that's just symbol notation. It's set notation. We might use that occasionally. Okay, a relation can contain different ordered pairs with the same x value or y value. A function can contain different ordered pairs with the same y value, but not the same x value. Okay, if we have different y values and the same x value, for instance, 1, 6 and 1, -2, we get a vertical line. Okay, now let's look at example 1. It's the first type of problem we have. The domain. Remember, the domain is the x, the range is the y. So let's look at the x goes from here to here. Okay, so that's -2, that's +2. So your domain goes from -2 is less than or equal to x is less than or equal to 2. It's less than or equal to because the lines are closed in. Okay, we're closed at the points, so we've got the equals part. Now the range is up and down. It goes from here to here. Okay, we've got y. Y is the range. Again, they're closed up both points. Well, here's our axis here. So the smallest y can be is 0. And then 1, 2, 3, 4. The highest it can be is 4. So there's our domain and there's our range. And is it a function? The idea with the function is we check, can it pass a vertical line test? Okay, these are all vertical lines. Each vertical line only hits it once. So it's okay. It's a vertical line test. It passes the vertical line test. All right, we'll look at ones here in a second that don't. Okay, let's look at B. We look left to right. We want to find the domain. Okay, the domain. We go left to right. This is the farthest left it goes. This is the farthest right it goes. It's equal at those points. So it's between those 2 points. That smaller value is -1 because here's our origin, right? and then positive 1. Let's look at the range. Well, we've got an arrow going down and an arrow going up. So there's no minimum and no maximum. It goes forever in both directions. That means it hits every number on the number line. Well, every number on the number line is all real numbers. Okay, so the domain, our range, or our domain stops at -1, goes from -1 to 1, and our range goes from negative infinity, which is way down here, negative infinity to positive infinity. That gives us our full amount. Now, let's talk about function or not a function. This one is not a function because it fails the vertical line test. You see this vertical line I just put, this blue one? It crosses it everywhere on this line. Okay, same thing happens over here. It fails the vertical line test. So if it fails the vertical line test, that means it is not a function. Okay, whereas this one passed the vertical line test, 1A, 1B does not. Okay, so 1, 2 are the same things. We'll look at those tomorrow. I'll refresh you about those at the beginning. Now here, example 2. We want to graph the relation 2, 1, 3, -1, 2, 3, -1, 2, -3, 0, and tell whether it is a function. If it is not a function, we draw a vertical line that intersects the graph more than once. So let's just graph those points. 2, 1. 2, 1. Right 2, up 1. 3, -1. Right 3, down 1. 2, 3. Right 2, up 3. -1, 2. Left 1, up 2. -3, 0. Left 3 on the origin. Okay, is it a function? We have no points. Do we have points stacked on top of each other? We do. 2, 1, and 2, 3. This gives me an issue right here. We fail the vertical line test. Okay, if we fail the vertical line test, that means it is not a function. Okay, we're always supposed to find the domain and range. Okay, we weren't supposed to find the domain and range. So 5, 6, 7, 8, 9, 10 are the same. Okay, so that's pretty straightforward. We'll talk more about it Friday in class, or when we actually cover this in class, and I'll refresh your memory on those. And that's the end for Chapter 3, Section 10.